Hello to all science lovers. I made this video inspired by a short film called His Powers, or Power of 10, that I watched during my university years when social media was not as widespread as it is now. In my opinion, this was the beginning of everything. So what are his powers? If you are ready, let's take a look at how insignificant a size we are in the universe. Starting from the largest, let's take a look at this beginning. It is the 27th power, which is when we put 27 zeros next to 1. These measurements are formed by light traveling 300,000 kilometers from one end to the other in 100 billion years. If the observable universe were in a single photo, it would look like this. Isn't it interesting? But what is really interesting is that, although 13.7 billion years have passed since the Big Bang, according to the expanding universe model, this photo confirms that the space fabric, with a diameter of 93.4 billion light-years, has a speed exceeding the speed of light. We do not know what is outside the universe. It is 25 to the power of 10, which means light travels this distance in 1 billion years. It is formed by thousands of superclusters, such as the Virgo supercluster, which includes our Milky Way galaxy. These brightnesses, it forms the cosmic web of our universe. One of these bright points that it sees in the dimension of 10 to the 23rd is our galaxy, the Milky Way. When we go down to the diameter of 10 to the 21st meter, that is 100,000 light-years, we observe our Milky Way galaxy. This galaxy contains 250 billion stars. In other words, light reaches from one end of the Milky Way galaxy to the other in 100,000 years. We see the local bubble in the Orion arm of the 1,000 light-year galaxy, which also includes our Sun. When we enter this arm, which is surrounded by thousands of stars and gas clouds, we reach our neighboring stars with a diameter of 10 light-years. Light can only travel from one end to the other in 1 year. Our Sun is at the center of this Oort cloud. Around this Oort cloud, millions of icy rocks rotate. Sometimes these rocks leave their orbit and form comets. The solar system finally emerged. The Kuiper Belt, which includes Pluto and thousands of dwarf planets, and in that order, Neptune, Uranus, Saturn. The largest planet in the solar system, Jupiter, the asteroid belt located between the 4 outer planets and the 4 inner planets. And then Mars, Earth. There is only the Moon and the Earth. How? Lonely we are, isn't this size? Is our world's diameter is 10 to the power of 6 now. We are on the scale of countries here. We put 5 zeros on one side. On this scale, there are cities. These dimensions you see Ant Kabir, which is 72 meters, 10 to the power of 0. This number is 1 meter. In this video, we came from automata, and we will go to micrometer. I hope you understand why we call it metric system, and that it has humans at its center. This level we have descended from human size is as big as our eye. This level, which is 10 to the power of -2 meters, is approximately centimeters if we enlarge it a little more. We see our blood cells 10 to the power of -5, which is 10 micrometers. This measurement is 10.000 dimensions. We are at nanometer level now. We see DNA in the chain structure where our genetic information is stored. These molecules that make up DNA contain atoms such as hydrogen, oxygen, nitrogen, carbon. Atoms, which are too small to be seen with the naked eye, can only be examined with powerful devices such as atomic force microscopes. 10 to the power of -10 meters, a 100 picometer atom, has these dimensions. Doesn't it resemble the solar system? Let's continue. You see the nucleus, which is almost the entire mass of the atom, but is 1/100,000th smaller than the atom. Doesn't it seem interesting? Neutrons and protons are held together by the strong nuclear force in this nucleus. 10 to the -17 meters, or 10 attometers. This dimension is dominated by the up and down quark particles found inside. The protons and neutrons, quarks, are also of various types: up, down, strange, charm, bottom and top quarks. There are 6 types in order of magnitude. Aren't there many of them? In the subatomic world, there are many terms such as mesons, baryons, gallions, neutrinos, leptons, and so on. These terms are more numerous than the variety of fruits and vegetables in a market. I feel like you are confused. But as Richard Feynman said, those who say they understand quantum physics have not understood anything. Anyway, we have a long way to go. Let's continue. We are making the size of the up and down quarks a little bigger. This is strange. What we see is strange. And the charm quark, this quark, has taken the name charm because the symmetry it carries to the subnuclear world fascinates physicists. Here, the bottom quarks are in the dimensions of a zeptometer, 10 to the -19. Here the bottom quarks are in the dimensions of a zeptometer, 10^2. The -20, 10 to the -21. There was no such thing. We see the top quarks at this scale, 10 to the -23. In other words, in 10 yoctometers, we finally see the last piece of neutrino. They pass through matter without interacting at all. Their electrical charge is 0, and they travel almost at the speed of light. Do you think there is a smaller one? Let's take a look. 10 to the 25. In other words, 0.1 yoctometer, 10 to the -27. In other words, 0.001 yoctometer. (10 to the -30). In other words, 0.00001 yoctometer, 10 to the -32. In other words, after 0, 7 zeros, and then we are in a yoctometer. There is nothing, completely empty. Yoctometers are as the name suggests, there is nothing. Let's enlarge the image even more. 10 to the -33, 10 to the -34, 10 to the -35. And finally, we start to see the Planck length, the smallest unit of measurement in theory. It is accepted as the unit of measurement of the theory of everything. Some scientists claim that strings vibrate in this dimension, while others say that it consists of quantum foam that forms the fabric of space-time. We do not know what is beyond the Planck length, just as we do not know what is outside the observable universe. Do you think that what is smaller than the Planck length is the same as what is outside the observable space? Do not deviate from science and technology, and stay happy.